Question of the week from the Naked Scientists.
Hello and welcome to Question of the Week from the Naked Scientists with me, Dr. Hannah Critchlow. Well, with New Year's resolutions in full swing, here's a sweet thermal caramel quandary for us to sink our teeth into.
This is Jeff from Encinitas, California. I made several batches of caramels over the holidays using a recipe that combines corn syrup, brown sugar, condensed sweetened milk, and butter in a saucepan. This year I was using a new digital thermometer and was surprised to observe that rather than rising at a constant rate throughout the entire cooking time, the temperature would rise steadily for a few minutes, then remain constant for several minutes, and then start rising again, repeating this several times through each batch of caramels. Why would the temperature rise so inconsistently?
So why should sticky stuff in the pan get hotter in stages? With the answer, here's Cambridge University PhD student Amy Chesterton, who specialises in the chemistry of cooking.
When you add heat energy to a simple substance, it leads to an increase in the kinetic energy of the molecules, so the temperature increases. If we drew a graph of this, the temperature would increase along a straight line as we added more heat energy. Sugar syrup isn't simple though, because there are chemical bonds between the atoms that form the molecules and even between the different molecules. These hold the water molecules and sugar molecules together, preventing them from evaporating when the mixture is cool. When the mixture is heated beyond a certain temperature, it begins to boil. This causes the molecules of water to break apart from one another, allowing the water to escape as steam. This uses up energy, so the temperature increases more slowly while this is happening. At other temperatures, sugar molecules themselves begin to break apart, which also consumes energy, again slowing the increase in temperature when this happens. And at other temperatures, the sugar molecules begin to bond together to form long chains, which is what is happening when you actually make caramel. Forming new bonds like this releases energy, which causes the temperature of the mixture to increase more quickly. This is why it's hard to only slightly caramelize sugar without burning it. So returning to the graph analogy from earlier, if you plot a graph of temperature against time for heating sugar syrup, there would be flatter areas where bonds are breaking and steeper ones where they are being formed.
So, the inconsistent rise in temperature that Jeff observed whilst cooking his caramels was due to bonds between water molecules and inside sugar molecules being broken, and new bonds being made as the caramel cooked. This caramel cooking conundrum caused quite a stir amongst all of you. According to retired science teacher John Wynnum from Sussex,
in the case of the caramel, the solid sugar will reach its melting point. Now, when a solid melts, the forces of attraction that hold the particles of the solid together in a lump start to loosen and break. And it's this process that absorbs the energy supplied instead of it being used to make the particles move faster. And consequently, the substance will stay at about the same temperature until melting is completed. Hence, the temperature of the mixture will not constantly rise.
And by email, Phil Sands from Portsoy, Scotland, as well as Blind Pete, who wrote on our forum, both correctly speculating that this effect was down to phase changes, similar to when ice melts to make water. So, with that quandary sorted, next week we'll be getting our heads around a question from Gerard Dunn.
I've always been told that there are no pain receptors in your brain, so what I would like to know is why does it feel like the pain is inside my head when I have a headache?
So what's going on in your head during a headache? Send your thoughts to chris@nakedscientist.com, tweet @nakedscientists, write on our Facebook page, or join in the debate on our forum, which is at nakedscientist.com/forum.
The Naked Scientists Question of the Week, brought to you in association with the Houter Wisman Foundation, supporting science and education from Alpha to Omega.